Fn of x equals n squared x squared times 1 minus x all to the power of n. X is in the closed interval 0, 1. N is in the set of natural numbers without 0. Let the maximum of Fn of x be an. Find the smallest term of the sequence an. This video contains the following sections. Reading the problem carefully and understanding it. Developing a plan to solve it. Solving the problem. Thinking about it further and try to apply the approach to other problems. Near the end of the video, there's an additional question which can be solved using a similar approach to that used for solving a specific problem. If you find these helpful, please subscribe to the channel for notification of new videos by pressing the video watermark in the right-hand corner of the video player. X is in the closed interval 0, 1. N is in the set of positive integers. So the function has non-negative values only. It's 0 when x equals 0 or 1. Find the maximum of the function first, then the general form of the sequence can be worked out. The maximum of the function can be found by setting the derivative of the function to 0. Then work out whether the sequence is increasing or decreasing. Then find the smallest term of the sequence. To find the maximum of Fn of x, we can derive Fn dash of x. Fn dash of x equals 2n squared x times 1 minus x all to the power of n minus n cubed x squared times 1 minus x all to the power of n minus 1, which can be written as n squared x times 1 minus x all to the power of n minus 1 times 2 minus n plus 2 times x. Let fn dash of x equal 0. We have n squared x times 1 minus x all to the power of n minus 1 times 2 minus n plus 2 times x equals 0. So x equals 0. 1, 2 over n plus 2 substitutes x in fn of x. We have fn of 0 equals 0. fn of 1 equals 0. fn of 2 over n plus 2 equals n squared times 2 over n plus 2 all squared times 1 minus 2 over n plus 2 all to the power of n, which can be written as n squared times 2 over n plus 2 all squared times n over n plus 2 all to the power of n, which can be written as 4 times n over n plus 2 all to the power of n plus 2. To check if fn of x is maximum when x equals 2 over n plus 2, we can check the value of fn double dash of x when x equals 2 over n plus 2. fn double dash of x equals n squared times 1 minus x all to the power of n minus 1 minus n squared times n minus 1 times x times 1 minus x all to the power of n minus 2 times 2 minus n plus 2 times x minus n squared x times 1 minus x all to the power of n minus 1 times n plus 2. Now we substitute x equals 2 over n plus 2 in fn double dash of x. First, we look at the first term of fn double dash of x. A part of this term is 2 minus n plus 2 times x. Substituting x equals 2 over n plus 2 in fn double dash of x means 2 minus n plus 2 times x becomes 0, as 0 times any number gives 0. So substituting x equals 2 over n plus 2 in fn double dash of x means the first term becomes 0. So fn double dash of x when x equals 2 over n plus 2 is minus n squared times 2 over n plus 2 times 1 minus 2 over n plus 2 all to the power of n minus 1 times n plus 2. After looking at each part of fn double dash of x when x equals 2 over n plus 2, we know that fn double dash of x when x equals 2 over n plus 2 is less than 0, because fn double dash of x when x equals 2 over n plus 2 is less than 0. So when x equals 2 over n plus 2, fn of x is maximum. So an equals 4 times n over n plus 2 all to the power of n plus 2. To find the smallest term of the sequence an, we check whether an is increasing or decreasing. N plus 1 over an equals 4 times n plus 1 over n plus 3 all to the power of n plus 3 over 4 times n over n plus 2 all to the power of n plus 2, which can be written as n plus 1 over n plus 3 times n plus 1 times n plus 2 over n times n plus 3 all to the power of n plus 2, which can be written as n plus 1 over n plus 3 times 1 plus 2 over n times n plus 3 all to the power of n plus 2, which is greater than n plus 1 over n plus 3 times 1 plus n plus 2 choose 1 times 2 over n times n plus 3, which is equal to n plus 1 over n plus 3 times 1 plus 2 times n plus 2 over n times n plus 3, which can be written as n plus 1 over n plus 3 plus 2 over n plus 3 times n plus 1 times n plus 2 over n times n plus 3, which is greater than n plus 1 over n plus 3 plus 2 over n plus 3 equals 1. So an plus 1 is greater than an. So the sequence an is an increasing sequence. So the smallest term of the sequence an is a1. Why? Why isn't it a0? Because we know that n is in the set of natural numbers without 0. a1 equals 4 times 1 over 1 plus 2, all to the power of 1 plus 2, which is equal to 4 over 27. Think about the thought process for the previous question further and try to apply the approach to other problems, such as this one in the sequence an. a1 equals 2. an plus 1 equals an squared minus an plus 1. Proof: 1 over a1 plus 1 over a2 plus so on plus 1 over a 2022 is less than 1. You can write your answers in the comments section if you like. If you have any mathematics questions of interest, you can write these in the comments section if you like. Thank you for watching. Hope you found this video helpful. See you next time.